A brief introduction. My name is Andy Woodward. I work for a company called GPEC Limited. We are a consultancy firm who represent a number of principals in the industry. One of those being IMI Critical Engineering for the aftermarket business. Today's presentation is in conjunction with those, but I'd just like to spend 5 minutes just to introduce GPEC, who are the InstMC member. So as I say, we exclusively represent what we call principal partners. These are all OEMs of equipment for the industry, oil and gas, petrochemical, chemical, power, waste to energy markets, what we class as niche and specialty applications in severe and critical applications, primarily across the UK and Ireland. The business proposition that we put forward is to work closely with the OEMs, between the OEMs and the end users, providing that technical and commercial value added input. We have the products that we represent, the principles that we represent all have advanced valve engineering within their portfolio and in their specialty areas. And as I said, IMI being the primary one that I represent. In that, we also offer a reselling of inventory products, so a buy-sell also into the marketplace. But there is that synergy between the products that we represent. We're a small company. It's a family-owned company. Scott Gower being the managing director, and with Sean Gower, his nephew, sales manager, and Lauren Gower, his niece, providing sales in the power market for some of the products that we represent. Myself and Tony Selby, between us, we have probably close to 60 years experience within control valve applications throughout the UK. I look after the north, Tony looks after the south of the UK, and between us we cover the whole of the IMI critical engineering portfolio. Louise worked closely with Scott for many years. She's our operations director, and Sam being the operation executive, and we have a consultant, Paul, who's our QA manager. The targets, the markets that we look into, as I say, it covers all industries, oil and gas, petrochemical, chemical refining, nuclear, power generation, the waste to energy as well. These are the principles that excuse me, that we represent across our portfolio. Myself and Tony, our primary responsibility is the IMI critical engineering portion, mainly with the CCI aftermarket control and choke valves in those industries. But we also have ATV valves, VE, Vermeer, heat exchangers, Comproflex, metallic expansion joints, Decotter, HF, Alki, chemical valves, Quadax being triple offset butterfly valves, and then a couple of other vessels and catalysts companies that we also represent. But as I said, there is that synergy between all of these products. Today's presentation is like I say, is focused on CCI, IMI CCI. That's just a snapshot that we present to show exactly what CCI can do. But I think most people who are on the call will probably know and understand who CCI are, the forerunners of critical application control and choke valves in the oil and gas and power markets. Aftermarket for the retrofits, upgrades, and the advances in the technology that they've been doing over the last few years has led us to where we are today. And today's presentation in additive manufacturing, and how, you know, the benefits of that in today's market for control valves. So yeah, we provide that relationship between OEMs and end users. We've done it for the best part of 12 years now. So you know, it's working, and any questions, queries or anything, you know, I can be contacted for discussions after that. Okay, so I'll stop sharing my screen. I've talked enough now, and I'll hand this over to Bertrand, who can continue with what we're all here for today.
Thank you, Andy, and good afternoon. Thanks a lot for the opportunity to present today. So if you have any questions during the presentation, feel free to raise your question at the end of the presentation. So today we'll be talking about additive manufacturing in control valves, and one of the initiatives that we want to show, which is the one which is the most advanced, I would say, within the IMI critical engineering additive manufacturing portfolio of initiatives, is what we call Retrofit 3D. So it's using additive manufacturing as a way to rejuvenate or retrofit valves that have problems in the field. And I'll take you through the why additive manufacturing is really a game changer for this retrofit activity. So, but just a few words about myself first. So I'm a French national, as you can hear by my accent, probably. So I've been working in the oil and gas business sector for almost 15 years. I used to work in the drilling and completion side of the oil and gas sector for a pipe company. I started additive manufacturing around 6 years ago now, almost. Initially for drilling tools, and then more recently on control valves with CCI. So I'll have a couple of slides at the beginning just as a company overview, plus also on control valves itself, the drag technology, and how we use the legacy drag technology invented by IMI to leverage new solutions for customers. And at the end of the presentation, I'll be taking you through a couple of interesting case studies that hope will be also good material for discussion during the Q&A. So just a couple of slides on the IMI group. I promise it's going to be short. So IMI PLC is the mother company of IMI Critical Engineering. So the IMI PLC has 3 divisions. So IMI Precision Engineering, which is creating motion control and fluid control technologies. They are typically cylinders and manifold. They're produced in a high volume series, mass production, and they are used in application where precision, speed, and of course reliability are very important. Hydronics, which is in orange here, is providing a hydronic distribution system. They are used in residential and commercial sectors for energy efficient heating and cooling systems. And IMI Critical Engineering in blue on the divisions there is the division I represent today. And so we operate mainly in oil and gas sector, power generation, nuclear as well, petrochem, so marine sector as well. And the typical brands that was mentioned also by Andy is IMI CCI, but there is also all the IMI Bopp and Reuter, STI as well for the actuator, ZNJ, etc., etc. So IMI has a global footprint, and you can here appreciate the different locations where we operate, whether it's IMI Precision, IMI Critical Engineering, or Hydronic. Overall, the group has close to 6,000 employees worldwide, and is generating an overall revenue of close to £4 billion. Okay, so it's also on the FTSE stock market as well. Okay, so enough about IMI Critical Engineering. So now next, let's talk about the control valve themselves and Retrofit 3D, this innovation that use additive manufacturing. So why we look at that, and so you guys on the call here knows pretty well the control valves, but so really the challenge in these control valve, as you know, is all about erosion, cavitation, the leakage, even vibration, and so severe sometimes that you can have parts separated and breaking up. And so all of that is linked to the fluid velocity control. And I have a good analogy here that I would like to share as well. So the analogy is this one. So if you have a waterfall, you have all this water, having a high elevated energy, and then that drops below on the cliff. And so this creates a kinetic energy that actually creates a lot of damages. So what you see at the bottom of a waterfall is typically like a big hole, right? And so that's this kinetic energy that is creating this hole continuously. So, and then there is this multi-stage pressure drop. So how to control this kinetic energy is actually to create a pressure reduction step by step. And this is like, if you imagine now the water, instead of falling off a cliff, like the Niagara Fall, and you have the water actually going down a staircase, then you would control much better the fluid, you would control much better the velocity, and then you would have less damage. So, and this is exactly what drag technology does. It's a patented design that is almost like 50 years ago, 50 years old, that manages and really takes the pressure reduction on a stage by stage steps within the control valve, within the trim set of the control valve. So Retrofit 3D, what it is, it's about using this legacy drag technology of IMI critical engineering and reinventing or inventing the solution for the future. So using additive manufacturing, we can so it's a trim-only replacement solution. So we can, with the technology, and have a slide later on, redesign a trim set more efficiently, within a more compact design, and with better rangeability within an existing body. And I'll show you how this can be done. But this is in essence because the additive manufacturing allows really a freedom of shape that the traditional process doesn't enable. It's also focusing primarily on the internals of the valves, like the trim, the seats, the stem, and the plug. And these are non-pressure boundary components. And so I'm sure you know that, but ASME, so all our pressure boundary components, they need to refer to an ASME class. And so ASME is not yet at the stage where additive manufacturing has been allowed by the code. And so here we are talking about the pressure. We are not talking about the pressure containing parts. We are talking about the internals, which is then fine for the use of additive manufacturing. Also, the big benefit, obviously, of replacing only the internals is that this is a much less intrusive maintenance operation. So you only have to remove the actuator, the bonnet, take out the parts inside the valve, and then drop in a new trim set. So if, for instance, you have a welded in place valve, you don't have to cut out the valve, weld a new one, do all the ND, etc. With a retrofit, you can actually enhance or upgrade your parts without having to do this intrusive maintenance. Also, no risk, and I say can always go back, meaning that the retrofits that we do as part of Retrofit 3D using additive manufacturing doesn't alter the body nor the bonnet in a way where the existing spare parts could not go back in. if it makes sense. So there is no alteration. So if there is a willingness to go back or only change the process condition for a period of time, then this is always possible with the technology. And then it's an upgrade and not a replication. And I'll show you a couple of case studies afterward. Okay. Additive manufacturing, and this is the point I was making earlier. So with additive manufacturing, we can actually shrink significantly the volume of the part with the same characteristics. So we can really have a much more compact design. And this reduction in volume is really the game changer of additive manufacturing in retrofit activities for control valve. I mean, retrofit has been there for some years now. It's not a new thing, but additive manufacturing is really the game changer because it allows this compact design. And I'll show you some examples of rangeability that we can give or where we have had projects with high rangeability trims in the past. Okay, but so first, what is additive manufacturing? So additive manufacturing is really a process, okay, where everything starts with a 3D or CAD model, and this can be as complex of a part as an engineering engineer can think of. And this is also the beauty of the retrofit 3D solutions, is that we can really tailor-made every single trim to a specific process condition. And typically, in fact, when you have this leakage or this cavitation, these damages in the valve, they can be because it was not designed. I mean, most of the case, it's because it was not designed to be operated the way it is operated today. And so this is really where the retrofit 3D, using additive manufacturing, we can redesign the trim and tailor make it to the existing and current process condition. So again, starting with the 3D CAD model, it's then being sliced by a slicing tool, sent to a printer, and I have some pictures just after. The printer will print the different layers one after another on a powder bed machine, for instance, and then the part will be completed with some post-treatment in some cases. So the typical post-treatment would be removing of supports or grinding or a heat treatment, for instance. So one thing I wanted to also highlight in this call today is when we talk about additive manufacturing, it's actually a lot of different types of processes. So this is a picture from hubs, 3dhubs.com. Okay, and this shows the different number of processes that does exist as part of additive manufacturing. Additive manufacturing is a fashionable name nowadays, and so a lot of people are using it. So we need also, when we talk about additive manufacturing process, really be clear about what is the process that is being used. And in our case, it's what's called DMLS or SLM solution, so direct metal laser sintering. So these 7 families are according to the ASTM process. And one thing I wanted also to highlight here is additive manufacturing is known in our general, everyday life for creating like plastic tools and these kind of things. But this can also be quite serious stuff when we are talking about metal printing. And I'll have some examples today as well. And this is here this stack being printed, so you can see here the different layers. So the number one is the bottom plate, and then starting to grow the part up to a finished component that you can see on picture number 4 that has the D-stack plus a couple of coupons here that we printed along with the printing of the part itself to be able to extract mechanical properties. So really the 4 advantages to additive manufacturing is the design optimization. So again, really being able to tailor-made a trim set to a specific process condition, optimizing the design. So if you need, for instance, a very fine low flow control, and then you still need some rangeability on the full stroke opening. This is possible. We can do like 2-in-1 solutions where you have a slotted cage and then also some drag type multi-stage control element at the bottom. So this really creates the opportunity for a design that is very suited for, I mean, tailor-made to the process condition. It's also a complex shape and complex geometry. So typically the trim sets and this stack are complex geometries by nature, for instance, and this is also how it can really enable new opportunities. A 40 turns disc stack is not even possible with traditional manufacturing. With additive manufacturing, we can really get these kind of tortuous passages up to the maximum allowable real estate within the cage itself, and have up to 40 turns, for instance, which is not at all possible with EDM. We're talking about also short deliveries, a typical printing speed of a D-stack. So depending a little bit on the size itself, but it can range from 2-3 days up to 10 days for the very large ones. I'm talking about the printing process itself. So I'm not talking about the overall lead time where it needs also post-treatment, but this also gives an indication of how fast the process can be. So really a couple of days. And then the last one is what I call rapid manufacturing. It's also the way where additive manufacturing doesn't require the same level of stock, because it's so fast and because it's so flexible. It doesn't require the same level of stock that the traditional process does require. And so in the additive manufacturing landscape, people are talking about what's called digital warehousing. So you no longer store the part, you only store a digital file that you do print on demand as and where and when needed. And so this is really the breakthrough that additive manufacturing is bringing to the industry. And if we are talking, for instance, about the marine industry or the oil and gas industry, that are perhaps the most advanced of the industries where we have these large assets for IMI critical, that's where these industries are paving the way for what's called this digital warehousing, and creating a new ecosystem of supply chain, where you have a CAD file, some powder to print, you print, and then you deliver as close as you can to the point of use. And so this is the typical new ecosystem that is being driven by the industry using additive manufacturing. So now a couple of case study examples. This is one of the very first one, and here the reason I show this one is because it actually shows clearly that the Retrofit 3D is more than it's not a replication, and it's really bringing a technology and upgrading a valve within the existing Bondi condition. And so you can see on the left-hand picture, this is a typical multi-stage trim that you can get from I don't know, Cascade or even ABJ for our product. And this is this kind of technology suffers some cavitation when it's at the low opening, at the low stroke. It usually creates some cavitation. And so the customer here in that case was having some change in process condition. He needed to operate the valve at a lower flow, and so that's where we upgraded the valve with a drag system, a drag technology, and you can see the new design on the right-hand side with a cage, 16 stages in this one, to provide rangeability and provide a better control on the high drop pressure that this application was needed to have. So this is one of the very first retrofit we did when the initiative started back in 2019. Since then, we've done many more retrofit, and we've also worked on other applications. So this was also in Inconel 718 type of material. In case you're wondering what was the material used. This one is interesting as well. So this is a choke valve. Again, it's in Saudi Arabia. So this one is more recent. This was installed in June 2021, opened up in January 2022, and then we changed the seals, and the trim is back in operation. And so this is also an area. So you can see here the original parts that were used for this application. And here we use the additive manufacturing to tailor-made this design and really create a two-in-one solution, as I was mentioning earlier. So really having these passages at the bottom where there is the low opening flow, being able to better control the flow and the velocity at the low flow, and then still have this high flow on the when the stroke is maximum. So this is typically, and I think this is a good example of the flexibility of the design, because such a part is not possible at all with a traditional EDM process. And so here, additive manufacturing brings really a new opportunity on answering customer problems. Another one here, it's a steam let down valve. So I was talking about heavy vibration earlier. So again, this was a customer this time in the US, an oil and gas refinery, who was facing some issues with their OEM parts. Heavy vibration, so much so that even the plug stem separated together. So we look at the valve, we look at how we can redesign the trim inside the valve itself. And so we added a couple of stages just to bring reduce the vibration and manage the kinetic energy better. And so this is one of the retrofit 3D design here that you can see. So that's so I talked about the trims themselves and what we can do, but this is only the tip of the iceberg, I would say. With additive manufacturing, the opportunities are beyond the drag and beyond the trim set in control valve themselves. So we've, for instance, done some seat baskets also in the past, where we needed to have, for instance, some pressure reduction stage within the seat basket itself to better manage the flow inside the valve. Some baffle plates as well. So there are really great opportunities with additive manufacturing to tailor-made components and be able to address specific flow condition in specific application using this technology. Okay, so that's it for the presentation.